right, so now we're going to move over to Couchbase and Frank Weigel, who's the director of product.
So Couchbase, we changed our name a lot, which is probably why people might not know Couchbase. But we used to be called Membase, and then we merged with a company called Couch One. And it's actually interesting because of some of the things that we heard. We are basically the start of some of the maybe consolidation in the NoSQL space. Membase is actually a very successful key value store, distributed key value store. We are behind Zynga. I'm sure all of you have had the pleasure of playing various social games, and Farmville and all the other ones that Zynga has with 240 million users per month is actually powered by Membase under the hood. So specifically, it's Zynga, so I shouldn't talk about any specific game, but in general, Zynga as a company is using Membase very heavily with well over 1,000 nodes. So this is the key value store, and then Couch One has CouchDB, one of the oldest NoSQL databases, came out in 2005 as a document store, as a document database from Damien, and that has been around and widely used for a while. And so we are now merged between the two companies, and we're currently in the process of unifying those technologies. And towards the end, I'll talk a little bit more about kind of what's on the horizon. What you see behind me, though, is a bit more detail of what's happening inside a Membase node. And I heard there was a technical audience, so I thought I'd take you guys maybe just a little bit in what's actually happening in one of these NoSQL databases, and then talk a little bit about some of the use cases. You can see we've got kind of two parts. On your left side, we've got the data path, and that's the thing that gives you your data, needs to give you your data fast. We heard a lot of the problems up here are all around performance. It's a general truth these days that you have more and more people who want your data at the same time. Either it's the same data or it's lots of different data. And that is difficult because it's just not what the traditional databases were designed for. And Michael already mentioned one of the common solutions that there is, which is you put a caching layer in front of it. And we actually have the people who wrote Memcached, or rather I think 70% of the Memcached code. And it was one of the starting points that we had, because there were so many people who had Memcached and then had a database layer to manage that as well, but they really needed to have the data in the cache, or otherwise they couldn't possibly meet their performance numbers. We ended up saying, well, why don't we just add persistence and replication to the caching layer, and then we have a system that can scale out horizontally, yet you still have your reliability and your data integrity on disk as well, so you can restore from backup if you need to. You've got your replicas if you need to fail over, during operation and so on. And that's the start of Membase, and that's actually in the beginning as a company kind of where we started. So that's what you're seeing on the left side, where we still have today this caching layer that is explicitly resource managed. And that's something that makes us a little bit different, I think, from most of the other solutions, is that we explicitly have this caching layer to which you can assign resources in which your data is cached, and then under there is the persistence layer on disk. And whenever you access data, you will always get it out of the memory layer, which is great because it's surprisingly, I know for many of you, you wouldn't know this, but it's a lot faster to write and read from RAM than it is from disk. We were very surprised when we found that out as well, but it is true. And so now we can, of course, get data access latencies that are well below milliseconds. I mean, we saw some other systems that also, when you read from RAM, you can get, even across the network, below a millisecond. We're talking about, hundreds of microseconds to get to your data, and that's fast. You can never do that if you have to go to disk, right? You have at least tens of milliseconds for a seek, and we're talking about a different category. Now, on the right side, what you see is what we call the cluster manager. And that's, of course, the other big challenge that you have is we always talk about scaling horizontal, meaning you don't want to have a bigger and bigger and bigger box because, well, at one point you have the biggest box money can buy, and then you're stuck. But scaling out horizontally is hard because now you have lots of systems that you need to somehow coordinate. And worst of it, the more of those systems you have, the higher the likelihood that some of them won't be there at any given point in time, or they might not respond when you try to talk to them and so on. And so for the clustering side, we're actually using Erlang. It's a distributed kind of language, functional programming language with some systems on top from Ericsson, designed for phone switches and stuff originally. Great at doing very high reliability systems that are distributed. And we're using that to manage the cluster as a whole, so when multiple nodes belong together to share the data. One thing we really like is that all of our nodes are exactly alike. So there are no special nodes of any shape or form whatsoever. All nodes have exactly the same code, meaning if you want to build a cluster, you can get a 1 RPM or deb package or Windows or Mac OS, whichever platform you want. You install that one package on your machine. If you want to build a cluster, well, you just install the same thing on another machine, and you go to the UI and point one to the other, or you do that via REST calls if you want to be fancy. And then you have a cluster. There is no special nodes that need to be configured and so on, which makes it very easy to scale up the system and to add machines. We literally have some of our gaming customers who say they don't have any sysadmins. I mean, we were talking about DBAs earlier. They go as far as having whole games that are their sole source of revenue running in the cloud, so they've outsourced the ops of their hardware to the cloud. And now with something as simple as Membase, they say, well, we just have some of our developer basically be the sysadmin to set this cluster up, but it's so simple and so fast, there isn't really anything why we need dedicated sysadmins anymore. Now, surely, if you go big enough, you need those again, but it's just it's a whole different ballpark compared to traditional systems where you would have very highly paid DBAs to take care of your database boxes and hope that they will stay up. So where do people use these systems? Because of the performance, ad targeting is one area where we're seeing a lot of success. In the ad targeting world, time is everything. Typically, you go and ask for information about the user, and then you try and decide which ad do they want to see, and then you hand that ad back to the person who's displaying the website. Now, there's very limited time because nobody wants to wait for the ad to be displayed. Right. And the thing is that the more targeted you can have this ad, the more revenue you're going to make as an ad targeting company, because if I show you the ad and you're going to click on it, they're going to get money. This means that nobody wants to wait at all to get the data from the database that has the user profile or targeting information and other information in there. They want to spend as much of their time budget as they can on using that information to decide which ad we're all dying to see. And that's where these features of the low latency and the consistent low latency really pays off. We had consistency earlier, and that's, again, it's thanks to this memcached layer in there and the clustering.
The caching is why you're able to
exactly.